All right, in 13.2, this section is called Verifying Trig Identities. It's exactly like it sounds. We're going to be given new trig identities, different ones than the ones we saw yesterday. And remember that definition is just a trig equation that's true. No matter what you plug in, as long as it's defined. You know, like we talked about, tangent has certain places where it's not defined. So do some of the other ones. So as long as the trig functions are defined, an identity is something that's true all the time, no matter what. So what we're going to be doing is we're going to take trig identities, something like example 1. Supposedly, this is an identity. So what we're going to do is we're going to prove it. Not like don't get freaked out by the word proof. I don't mean geometry proofs. We're just going to basically show that this side of the equation is the same as this side of the equation. And the way we're going to do that is with this. We're going to transform one side of the equation until it looks identical to the other side, and then you're like, oh hey, they're the same. So some tips. Some tips I would recommend. If we're going to transform one side, you're going to want to start with the more complicated side. Typically, addition or subtraction make an expression more complicated than multiplication or division. So if one side has addition or subtraction and the other does not, I would say start with that side. That's going to be a little more complicated. And then the way we do it is we just simplify and simplify as much as you can until the two sides are the same. Okay, so we are going to verify that this is an identity. So start with the more complicated side. So I am going to start with this side right here. Like I said, usually, not every time, but usually, if there's addition or subtraction involved, that's the more complicated of the two. So that's what we're going to do. So one big tip, and we've got a list of tips down here, use sine and cosine. Try to get things in terms of sine and cosine. I'll tackle these in just a second in the second half of the notes, so try to get everything in terms of sine and cosine. So remember, cotangent is cosine over sine. So since it's squared, they both get squared. And then minus cosine squared. So with the subtraction, we want to get a common denominator. So the cosine squared, what I'm going to do is I'm going to multiply top and bottom. All right, so think of this as like cosine squared over 1. I'm going to multiply top and bottom by sine squared over sine squared. So for the piece on the right, I'm really just multiplying it by a fancy 1, but then they'll both have a denominator of sine squared, and then I can combine them. Okay, so I've got cosine squared minus cosine squared sine squared, and I'm going to put that all over sine squared. Okay, so that's the first thing. That's a really good technique. A lot of times you'll need to get a common denominator. Next, up in the numerator, both of these terms, I have two terms, they both have a cosine squared, so I'm going to factor it out. So when I factor out the cosine squared, and then notice here, I've got 1 just left here. Don't forget about that 1. And then minus, now here if I factor out a cosine squared, I'm left with a sine squared. Okay, and then since I factored out the cosine squared, it's pretty much just sitting out front. We don't have to write it over the denominator anymore. You could even put this like over 1 if you're freaked out about where on earth the denominator went. And if you check, if you multiply the numerators together, you will in fact get this. If you multiply the denominators together, you will get this. If you kept the denominator, that would be like implying that our denominator was sine squared times sine squared, which it's not. So, next, this is just a cosine squared times, and then 1 minus sine squared. Hopefully you guys remember that from yesterday. It's just a slight variation on the Pythagorean identity. 1 minus sine squared is equal to cosine squared. And then over sine squared. All right, now this cosine squared, we are not changing it, times, finally, cosine squared over sine squared is cotangent squared. So now, there it is. It's just in a slightly different order, so I suppose we should actually write it in the proper order just to make it as exact as possible. And so you don't really need to box it up because it's not like this is your answer. Your answer is showing that, yes, this side does equal this side. So I usually just finish them off with a check. Like, yep, did it. Okay, next example. We want to see what this thing is equal to. So, like I said, the typical thing that you're going to do is get everything in terms of sine and cosine normally. This situation, hopefully you recognize this. We literally just used it. It's the same thing that we have right here. So cotangent squared minus cosine squared, according to this, is the same as this right-hand side. So all I'm going to do is just replace this. Okay, now let's write everything in terms of sine and cosine. So tangent is sine over cosine. So tangent squared just means both of these pieces get squared. And then in parentheses, cotangent squared is cosine over sine. Both of them are squared. And then times just a plain old cosine. It was obviously already in terms of cosine. And now these are going to cancel each other out. Now you may have recognized that from here. Since tangent and cotangent are reciprocals, they actually do just cancel out. When you multiply them together, you just get 1. So this is just equal to cosine squared, which is letter C in the multiple choice. Okay, so that was one way that you can make these equal to each other. One way that you can verify these identities. First category was transforming just one side of the equation. So again, what we did there is we picked the more complicated side and then just basically manipulated it. Just manipulated it until we got it to look exactly like the other side. The second way that we could do this is to transform both sides. Transform both sides and then show that they're equal to the same thing. It might be hard to show that like the left is equal to the right, but you might be able to show that left and right both have the same value or they're both equal to the same thing. Okay, so here's some general suggestions. You might want to substitute some basic trig identities, like we wrote here that tangent was sine over cosine. That's a good example. You might have to factor, you might have to multiply. We did some factoring in this problem right here. You might have to multiply both the numerator and denominator by the same trig expression. We did that here. That was like multiplying by a fancy 1. Write each side in terms of sine and cosine only. That's a great technique to use. We did that. And then simplify as much as possible. Once you do that, a lot of things will start canceling, so that's really good. Properties of equality do not apply to identities. Okay, so you can't like add or subtract. Do not perform operations. Okay, you can't like add to or anything like that. All we're doing is manipulating and rewriting. We're not doing operations. Okay? All right, so if you just flip, we just have one more problem. This is a beautifully short video for you. So this one we're going to be transforming both sides. So let's start with this. So let's do side 1, and we're just going to manipulate side 1 as much as we can. And then later, after we're done with side 1, we will manipulate side 2. The end goal is that they come out to be equal to the exact same thing. Okay, so side 1. Okay, so start with it exactly the way it's written. The next technique is that you're going to write everything in terms of sine and cosine. So cosecant is the reciprocal of sine, so it's 1 over sine. Since this one's squared, this one is squared. Cotangent squared is cosine squared over sine squared. And again, that's because cotangent is equal to cosine over sine. Next, we can combine like terms right now because they actually have the same denominator already. So we can just combine like terms. So I subtract the numerator, put it over a common denominator. Next step is that 1 minus cosine squared. If you remember from the previous lesson, and if you remember from the previous page even, this is just a rewrite of sine squared plus cosine squared equals 1. So that is actually equal to sine squared. And then my denominator is sine squared. Okay, and sine squared over sine squared is just equal to 1. Okay, so my first side simplified all the way down to just 1. Second side. Start with the way it's written. Okay, best technique is to get everything in terms of sine and cosine. Cotangent is defined to be cosine over sine. Tangent is defined to be sine over cosine. Okay, and if you didn't notice before, everything will cancel out. And remember, when everything cancels, you're not left with a 0, you're left with a 1. So side 1 ended up becoming just 1, side 2 ended up just becoming 1. So your conclusion would be something like this, like, yep, both sides are the same, therefore it's an identity. Ah, just cracked the 10-minute mark. I thought I was going to get a video under 10 minutes for you. All right, that's it.